Let x and y represents the length and width of the rectangle whose perimeter is given as 128 feet. And here we have to find the dimension such that the area is maximum. So first let's write the perimeter equation. So that is perimeter of this rectangle, and this equals it is twice of the length, that is 2x, plus twice of the width, that is 2y, and this is given as 128 feet. So we set up this equation, 2x plus 2y equals 128. Now we can divide both sides by 2, so we get x plus y equals 64. And from this, I'm going to solve for y, and so y equals 64 minus x. Now let's write the area equation of this rectangle. Let's represent this by a, and this equals the length times width, that is x times y. And we have to write down this equation in one variable. So we can replace y by 64 minus x into this equation. So this equals x times of 64 minus x, and when we distribute the x we get 64x minus x squared. So basically this is the area function which we can write down in terms of function notation as a of x. And using this area function we have to solve for x, or we have to determine the x such that area is maximum. So we are going to use the calculus first and second derivative test to determine that maximum area and also the corresponding x value. So first we have to determine the critical point of this area function, and this is obtained when we set up this equation, that is the first derivative equals 0, and solving for x. So let's find the derivative of a of x function, so which is a prime of x, and this equals the derivative of 64x is 64 times the derivative of x is 1, minus the derivative of x squared term is 2x when we apply the power rule. So this becomes 64 minus 2x. This is the derivative of the area function. And since we have to set up a prime of x equal to 0, replace a prime of x equal to 0. So we get 0 equals 64 minus 2x. Adding 2x on both sides, we get 2x equals 64. And now dividing by 2 on both sides, we solve for x. That is x equals 64 by 2, which equals 32. So basically, this is the critical point of the area function. Now we have to determine or test whether at this point this area is maximum. For that, we should find the second derivative of this area function. So let me use the first derivative of a of x and find its derivative, which is a double prime of x. And this equals the derivative of 64 is 0, minus we have this derivative of 2x, which is negative 2 times derivative of x is 1. So it is basically negative 2. That is the second derivative of the area function equals negative 2. And this is always less than 0 as it is independent of x. So there is no need to plug in this into this one. Even when you try to do that, it is always going to be negative as it is independent of x. And according to the second derivative, when the second derivative is less than 0, we see that at this point, that is at the critical point x equal to 32, it's a point of maximum. That is, area is maximum at this critical point. So this is how we verified at this critical point that area is maximum. So we can use the one of the dimension, that is x equal to 32 feet, and we have to find the corresponding other dimensions. For that, we can use this equation for y, which equals 64 minus x. So we plug it into the expression for y, which equals 64 minus x, replace x by 32, and this equals 32. So we see that y equals 32 feet, and therefore we say that the dimensions of the rectangle are 32 feet, comma 32 feet.